Plutonium is a dense, silvery metal. It does not exist in nature in any meaningful quantity, and every atom of it on Earth was man-made. The process starts with uranium, which is a naturally occurring element mined from the ground. Uranium is loaded into a nuclear reactor, where it is bombarded with neutrons. When a neutron strikes a uranium atom, the uranium absorbs it and becomes unstable. To stabilize itself, it undergoes a series of internal changes, shedding energy and particles, and in doing so, transforms into a completely different element, plutonium. Plutonium was first created in 1940 by a team of scientists at the University of California, Berkeley, led by Glenn Seaborg. When it came to naming it, Seaborg followed the pattern already established for the two elements before it on the periodic table. Uranium was named after Uranus, Neptunium after Neptune. Pluto was still considered a planet at the time, and it was the next planet in the solar system, so the new element became plutonium. What makes plutonium so powerful and dangerous comes down to how unstable its atoms are. Every atom of plutonium is constantly trying to break apart, releasing energy in the process. This is called radioactive decay. In a small, controlled amount, this release of energy is slow and manageable, but plutonium has a unique property. If you bring enough of it together, the particles released by one decaying atom start triggering other atoms to break apart, which trigger more, which again trigger more, in a chain reaction that multiplies in a fraction of a second. That chain reaction releases an enormous amount of energy almost instantaneously. This radioactive energy it constantly releases also means plutonium glows faintly in the dark and generates enough heat that a piece of it feels warm to the touch. Those exact properties, the unstable atoms, the chain reaction, the sheer energy released in a fraction of a second, are what makes plutonium the ideal material for a nuclear weapon. And the history of how it was first used as such a nuclear weapon starts with the two bombs dropped on Japan in 1945. The first bomb, dropped on Hiroshima, used uranium. It was a simpler design. Fire enough uranium together in one place and it reaches critical mass and detonates. The second bomb, dropped on Nagasaki 3 days later, used plutonium. Plutonium behaves differently. It cannot be detonated using the same simple method, because it would begin fission too early and fizzle out before a full explosion. Instead, it requires a far more complex design called an implosion device, where conventional explosives surrounding the plutonium detonate simultaneously and compress it from all sides at exactly the same moment, forcing it to critical mass instantly. That complexity is why uranium was used first, as the simpler design was ready earlier. Today, the vast majority of nuclear warheads use plutonium, precisely because that implosion design produces a far more powerful and efficient weapon than uranium alone. Uranium carries the public association with nuclear weapons, largely because of Hiroshima, which came first and became the defining image. But nowadays, plutonium is what powers most of the world's nuclear arsenal. Plutonium also has a use that has nothing to do with destruction. Because it generates heat continuously through its radioactive decay, it can be used as a power source in environments where solar panels don't work, deep space. NASA uses a specific 238 form in devices called radioisotope thermoelectric generators, which convert the heat from plutonium's decay directly into electricity. The Voyager probes launched in 1977 are still transmitting data from beyond the edge of our solar system, powered entirely by plutonium. The Curiosity and Perseverance rovers on Mars also run on it. The New Horizons probe that flew past Pluto in 2015 was powered by it as well. In the coldest, darkest corners of the solar system where sunlight is too faint to be useful, plutonium is the only power source reliable enough to keep a spacecraft alive for decades. Click the video on your screen right now, and I'll explain another everyday mystery you've wondered about your whole life, but never thought to look up.